Linux. Okay, first one, if I borrow this. So, from the homework, 1 part 5. Okay, 1 part 5. So we have B is here. A is here. And what we do is, remember, we take this B vector and we put it at the end of the A vector. So we move this B here to here. Okay. So then, this is the answer. Here. That must be who. Come on, what happened to you? Yeah. Okay.
Sorry, why do we do this?
Well, if you were, think about the last class. If you have 2 vectors and you want to add them together, you put one vector at the end of the other vector, and then this is the answer. So, you take this here, and I moved it to here, because that's at the end of the A vector. And then the answer is from the start to here. So this is the answer here. This is kind of the same, and this is part 5, this is part 6. This one here, if you look at it, you can see this is A and this is B, but you can see that B is the same as minus A. They're the same, they're just the other way around. So, what happens if you do A plus minus A? 0. Okay. Next now, number 6. So I give you 3 vectors here. A, C, and B. And first they ask you to do A plus B plus C, but B plus C is first. So we do B plus C, okay. There's B plus C. Can you see that? That's B plus C. And then we add that to A. So in green, let's add that answer to A. And that's A plus B plus C. Then they say, do it again, except this time, do A plus B first. So if we add A plus B first, well there's A, there's B, so A plus B will be roughly this one here, that's A plus B. And then we have A plus B plus C. It's supposed to be exactly the same. It's not quite the same because it's very hard for me to draw. The thing they want you to figure out in the last question is A plus B plus C is the same as A plus B plus C. That if you do this first, or if you do this first, you get the same answer. Okay? That's all they want you to learn from this question. Oops. Okay. Continue? Yeah. Alright. Whoops, oh dear. Vectors and scalars again. Next part. And the name of the lesson is, I'll just call it I and J. Okay, so it is not convenient to have to draw every single time. We don't like that we have to draw our vectors. So we're going to use these two special vectors called I and J. They're called basis vectors. I and J are perpendicular. You remember this word from math class? Yeah. I and J are perpendicular, and finally I and J are 1 unit long. So what we do is, this here we call I, and then this here we call J. So that's I and J. So I and J are very useful for us. Let's have a look at an example of why they're so useful. So I say, oh sorry, can I? Yeah? Okay. So I could say something like now, draw 5I plus 2J. So here is I, here is J, here is 5I, 1I, 2, 3, 4, 5I, and then here is 2J. 1, 2. Adding these together, you know how to do that. We go parallel, and we go parallel, so we make a nice rectangle, and then here is the answer. Here is 5I plus 2J. And what's great about this is I know how big the base is. The base is 5 units. And I know how big the height is. The height is 2 units. In fact, I can use Pythagoras, and I can know how long the new vector is. You know Pythagoras? Yeah? You know Pythagoras? His name I have no idea what his name is in Chinese or Cantonese or Mandarin or whatever. Do you know Pythagoras? No, you see, this is the problem. It's the same in it's the same name in Arabic, isn't it? Pythagoras. You know Pythagoras? Yeah. So yeah, in English he's Pythagoras, in Arabic he's Pythagoras. He doesn't have a different name, right?
How to spell?
Well, let's see. I'll do it better. I'll give you a translation.
Yes, good.
Yeah. I'm sure you know Pythagoras. He lived maybe, what's it, 2,200 years ago? No, 2,200.
BC.
He's Greek.
He did X squared plus Y squared plus
No, hang on. Pythagoras. There he is there. Yeah, Pythagoras. Yeah, you know Pythagoras. Oh, come on. Yes, okay, so we want, we have here English, Pythagoras, let's see. Right?
No, that's just the name.
Yeah, you know this person?
I don't know this person.
We don't know this person.
Is it about triangle?
Yes.
Yeah, I got it.
You know this person?
I don't know this person, but I know what.
Oh, okay. Do you know this person?
I don't know this person.
Oh, okay. But you can read this?
Yes, so it matters.
Oh yeah, look, there it is there. Pythagoras? Yeah. So, Ugo, I know you said it already, but what we'll look at now is Pythagoras' theorem. It's useful here. Do you know his theorem? With the triangle? I'm sure you all know it. This is x, this is y. So how big is this?
X and y.
Mm-hmm.
X squared plus y squared
Root. So this is useful when you have a vector. If you have xi plus yj, that's actually what I drew here. This is xi, yj, and this is the vector. So the length of the vector is given by this formula. This is how long the vector is, x squared plus y squared. So if you went back to the example before, this vector will be square root 27 units. That's how long it is. And we have a special symbol when we want to know how long a vector is, and we write these two lines around it. What's another word for length and size? I gave you it in the last class. Not well, distance, yeah, but another one?
Magnitude.
Magnitude. Do you remember this word? Magnitude? Yeah? Okay. So this is how you can get the magnitude. So let's just do one more formula. The direction is this angle here. This is the direction, theta. Would anybody know what formula I could use to find theta? What I could do to find theta? Yes. Yes, which one would I use? Well, we usually use tan here, normally. Yeah. So you have this. Now don't worry, we'll do this in maths class, but for today I'll just say tan theta is equal to y over x. So your calculator can tell you what the angle is. You type in tan inverse y over x. So on your calculator you usually have to press the shift button or the second function button and then press tan to do this.
Sorry, excuse me. What's the middle? X2?
Here?
Yeah.
Oh, that's a plus.
Plus?
Oh yeah. Yeah. And this example, great. You got, here is 21.8 degrees. Yeah. Okay, let's do one more example of this and then let's make it more difficult. Okay, so for example, draw, let's say 4i minus 3j. What is the magnitude and direction? Okay, so let's draw it first. So there's I, there's j. So we have here 4i minus 3 j. So that would be there. The magnitude is this formula. 9, which is 5. And the angle is this formula, tan inverse minus 3 over 4. Do you mind telling me what that is on your calculator, please? Yeah, it should be minus, yeah, what is it?
Minus 36.8.
Minus 36.8 degrees, because it's going down. So this angle here is 36.8 degrees. It's going down, that's why it's minus. If you got this in the exam, it would only be the first question on the exam paper, you know, just to get you started. It's not too difficult. Can I, oh no, you need to write it down, do you? Yeah. Did you end up taking a taxi this morning?
No, the bus came, yeah.
Yeah, but I was feeling like it would take too long, so I got the other bus, but I guess I made the bad choice because you got here before me. You got the 122.
122, yeah. They kept going back and forth between 1 minute, 2 minutes, 1 minute, 2 minutes.
But you managed to get here, it must have been just before me.
I think it was just before you, yeah.
Okay. Another reason i's and j's are useful is because they give us an easy way now to add vectors together. Okay, can I scroll down now? Yeah? Okay. So for example, let's say I say vector x is 5i plus 2j and vector y is I plus j. If I quickly draw that, just roughly 1, 2, 3, 4, 5, 1, 2. So for example, that could be 5i plus 2j, and then the other one here, yeah, I don't know, something like that. There's I plus j, roughly, very, very rough. If you want to add them together, you might say, oh, okay, I have to do this, and then I do this, and then I do this. But no, you don't. The great thing with using i's and j's is you can just add them together like in maths class. So for example here, I can see that x plus y equals, how many i's? 6i, and then how many j's? 3 j's. So you see it's much, much easier to add. Much easier to add. So this is the answer. Now, it gets better again. If I say x equals I minus 3j, I can tell you what 2x is, the vector that's twice as big. It will be 2I minus 6j. So that's great. It makes everything a lot easier to do now. Okay. I'm going to give you two vectors, and I want everybody to tell me what the magnitude and what the direction is of each vector, okay? So I want the magnitude and the direction. So the first vector is 5i, no, go with 3I plus 4j, and the second vector is 0.6I plus 0.8j. So what I want is the magnitude and the direction. So here, I want the magnitude. Oh, and by the way, this symbol here, we can use it to mean direction, but I'll just write theta. Direction. Theta 1. And then here, I would like the magnitude and the direction. Theta 2. Okay, so you need your calculator. Tell me what you get. And we'll call this vector here x and y. So this can be vector x. Where's my pen there? This is vector x, and this can be vector y. Okay. Do you have does anyone have any of the parts yet? Yeah. So firstly, I want the magnitude here of the first vector. So what do we get for this?
5.
We get 5. Okay. Then I'd like the direction.
53.13.
53.13 degrees. Do you know what to do? Yeah, or no? No. Shift, tan, okay, then you type in 4 over 3. Not over. Yeah. Okay, so that's the angle, that's the direction. Okay, Louise, I want you to tell me the magnitude here for this one. Okay, and then Saeed, I want you to tell me the direction for this one.
Shift and
Tan, yeah.
Okay.
0.8 divided by 0.6.
0.8
Mm-hmm.
divided.
Yes. 0.6.
10.
Oh, you're giving me the angle. I want the magnitude. Yes. We use our friend Pythagoras. You have both? Okay.
After that equal
Yes? What did you get?
0.92.
Oh, it sounds like your calculator's in radian mode. Can you hand me his calculator? It is in radian mode. Put it to degree. Okay, now hand it back to him. That's what the answer is. Do you see it?
Okay.
53.13. Okay, Louise, do you have this? Yeah, you know what to do? No, not that one. I want the magnitude. I'll show you.
Okay.
Magnitude, this is magnitude. How long?
Yeah.
Yeah. So far, what do we notice about these two vectors? Yeah, or using the other language, the direction. What can we say about the direction? Same direction. Yeah. Did you get this, Louise?
Oh, maybe I don't.
8% squared. Oh no, it's okay. I'll help you out. Yeah?
1.
1. Yeah. So if I draw this, you have something interesting here. Here's the first vector. And then here's the second vector, here's y. And as you said, Ugo, they're parallel. They have the same direction. But this vector, how long is this vector? Yeah. What's its length? How many units?
1.
1 unit. And then how many units is this one?
5.
5 units. So we can now say, here's a new vocabulary for you, y is a unit vector of x. You know this word? You've seen unit vector before? Yeah, it's a unit vector. So my question now is, if I give you a vector, let's say I give you something like 5i plus 12j, can you make that into a unit vector? Well, I want everybody to tell me how long this vector is. So can everybody work out the magnitude, the length? So how long is this? 13. If you use your formula, you get 13. So this vector here is 13 units long. How long should the unit vector be? 1 unit. So this is too big. How many times too big? It is 13 times too big. So if I want to make it smaller, if I want to make it 13 times smaller, what should I do to it? Divide by 13. So if you think about it, if I have this vector and I multiply by 2, what happens? It's twice as big. If I divide by 2, it's half. So if I divide this by 13, I get 5 over 13i plus 12 over 13j. That's the unit vector. So this is how you can make a unit vector. Okay, one more example, and then I'll let you try some. Now we'll give you a difficult one. Can I go down? Okay. Find scalars K and L such that Km, M is a vector, plus LP, P is a vector, is 2I minus 11j. And I also tell you that M equals 2I minus j, and P equals 4I plus 3j. So what you don't know in this question is you don't know the K and you don't know the L. But you do know the M, you do know the P, you know this is 2 and you know this is 11. So what I want to find is the K and the L. So what I do to solve this is I know the M, here it is here, and I know the P, so I can substitute that into my problem. So I get Km plus L, so this is the answer now, LP equals 2I minus 11j. Okay, we can expand, so we get 2Ki minus Kj plus 4Li plus 3Lj equals 2I minus 11j. Now, if you look at the left, you see you have I here and I here. And you have J here and J here. you can combine these together. So you have, what's the verb in maths class when you put the two together and take the I out? What's the verb for doing this? 2k plus 4li. What's that verb? Do you remember maths class, the verb here? Did it in the first class? I take the I out. Now open's the other one. Open is when you put the k in. If I want to go the other way. I forgot. Factor out. Do you remember factor out? Is that yes or no? Yeah. And then here for the j, I factor out as well. 3l minus k j equals 2i minus 11j. Okay? Now you might think, well, this isn't so useful because I still don't know what the L and what the K is. I still don't know what the L and the K is. But there's a trick here. I and J are independent. Do you know this word, independent?
Yeah.
Yes? What's independent?
I'm independent.
Good for you, yes. Independent means it doesn't relate to other things. What I mean here is this I and this J are independent. They don't go together. And this I and this J are independent. They don't go together. Or what I'm trying to say is the I here only goes with this I here. We don't have to care about the J when we look at the I's. And this J here on the left only goes with this J here on the right. On the left, how many I's do I have? I have 2k plus 4l I's on the left. How many I's do I have on the right? 2. They must be the same number. You know, it's like saying 2i equals 2i. If I said xi equals 2i, what's x? 2. Now, on the left I have 3l minus k, j's, and on the right I have minus 11j. Who remembers how to solve this from maths class, from your high school? What do you do? Yes? Simultaneous, yeah. So what's our first step? What should we do?
Second one by 2.
We can make
yeah, because the k's can be the same, can't they? So I think you're right, that'd be the easiest thing to do. If I have 2k plus 4l equals 2, and minus k plus 3l equals minus 11, and I should multiply this one by 2. So then I get 2k plus 4l equals 2, and minus 2k plus 6l equals minus 22. Now what do I do next? If you remember from high school. Add them together. So these go, and I have 10l equals minus 20. So what does l equal? Minus 2. Now, how can I find the k? Well, no problem. I just take this answer here and put it back in here. So now I have 3l minus k equals minus 11. So that would be plus 2, minus 2. I think it works. Oh, sorry, I said k, but I wrote l, did I? Sorry, wrong. No. Sorry, I should replace the l, not the k. 3L minus K equals minus 11. So that means minus 6 plus 11 equals K. So then that means K equals 5. Now let's check the answer. Yeah. That's the answer then. So I found K now. So now things are starting to get more difficult. You look confused, Saeed. Do you have a question?
Me?
Yeah.
Little bit, if you can repeat,
Which part?
the last part.
In the red or the green?
The green?
This green piece here?
Yeah.
Yeah. What I did was I add them together. So 2K and minus 2K, nothing.
Okay.
4L and 6L,
Okay.
10L. 2 and minus 22,
20.
minus 20, yeah. And then I just take the 10 underneath. And I get minus 2. So that's the L. Then I put L into this line. I replace the L. So I can find the K. So here's the replacement, and here's the answer for K.
Thank you.
Yeah, it's okay?
Yeah.
Right, now let me give you some questions to practice. So now the homework, yep.
Not sure.
Oh yes.